we're going to take a look at sum and difference formulas. These are extremely helpful when we are trying to find the sine, cosine, or tangent of items that are not necessarily unit circle values that we already know. Obviously, if we have sine of pi over 2, we already know that. That's a unit circle value that we have memorized. But we might be looking at ones that we don't have memorized. Okay? What we're going to start with are ones where we may not have them memorized, but we're going to use ones that we do have memorized in order to find them, because we're going to add or subtract two different items that are on the unit circle. The first thing that you want to do is make sure to copy these down. Okay, the first two listed are the sum and difference for sine. Sine of A plus B is equal to sine of A times cosine of B plus cosine of A times sine of B. Notice that the sine of A minus B looks exactly the same, except there is a minus between the two products. Then you have your cosine formulas. Cosine of A plus B is cosine of A times cosine of B minus sine of A times sine of B. Cosine of A minus B looks exactly the same, except there is a plus sign in between. Okay, so those are opposite. Notice that the sine, sum, and difference formulas, they had the same sign in between. If it was addition, it was an addition sign. If it was subtraction, it was a subtraction sign. Whereas cosine is flipped. Okay, so that's important to remember. And then you have your tangent formulas. Tangent of A plus B equals tangent of A plus tangent of B over 1 minus tangent of A times tangent of B. Tangent of A minus B equals tangent of A minus tangent of B over 1 plus tangent of A times tangent of B. Notice that these look really similar. The only differences is whether it's a plus or minus. And notice that you start out with the same symbol that you have. So when we have tangent of A plus B, then the top has an addition. When we have tangent of A minus B, the top has subtraction. And so those follow the same signs, and then the bottom is the opposite sign. Okay, that's kind of an easy way to keep track of which one you use. Okay, so let's start talking about what these look like when we're actually going to use them. Okay, and if you need to pause to make sure to write these down, feel free to do so. All right, so let's say that they ask us to find sine of, let's go with something, 5 pi over 12. Now, 5 pi over 12 is not one of our values that we're used to seeing. That's not a value where we know those trig functions for 5 pi over 12. That's not a value that's on a unit circle that we have memorized. But what we want to start thinking about are things that could add or subtract to get to 5 pi over 12 that would be on our unit circle. Okay, so a lot of times I just tell people to start playing around with it until you get something that works. What I mean by that is you don't have to have it simplified down to begin with. Let's just think about two things. Let's do addition. Let's say we're looking at two things that add together to equal 5 pi over 12. Okay, so what if we used 3 pi over 12 and 2 pi over 12? Those both reduce. Let's see what they reduce to. Are they things that are on the unit circle? That's the same as sine of pi over 4 plus pi over 6. Okay. Notice that pi over 4 and pi over 6 are both items that are on the unit circle, and we already know the values for. In this case, it doesn't matter which order you have these in, but I have pi over 4 plus pi over 6, so pi over 4 is like my A in the formula, and pi over 6 is like my B. Now, that formula for sine of A plus B was sine of A times cosine of B plus, cosine of A times sine of B. Now we want to plug in values. So we want sine of pi over 4, because that's our A, times cosine of pi over 6 plus cosine of pi over 4 times sine of pi over 6. Let's plug in those values. Again, this is where knowing our trig values makes these go a lot faster. Sine of pi over 2, or excuse me, sine of pi over 4 is square root of 2 over 2. We're going to multiply by cosine of pi over 6. Cosine of pi over 6 is square root of 3 over 2. And then we want to add now cosine of pi over 4, square root of 2 over 2, times sine of pi over 6, which is 1/2. Okay, if we multiply, we have square root of 2 times square root of 3, which is square root of 6, over 2 times 2, which is 4, plus square root of 2 times 1 is square root of 2, over 2 times 2, which is 4. Now we have a common denominator, so we can add these together on the top. We can't combine the square roots because they're not the same square root, and we can't simplify them down. So we can just leave this as square root of 6 plus square root of 2 all over 4. So that is the value of sine of 5 pi over 12. And we can find that without any calculator, without a decimal. Okay, so a lot of times this will say find the exact value, which means you want to find it without any decimals. All right, let's try another one. Let's say that we want to find, let's do one where we have to do subtraction. Let's say we want to find tangent of pi over 12. Okay, again, I would just start thinking about things that you could add or subtract. In this case, we're going to end up subtracting. Okay, unless we want to add a negative. But let's try looking at tangent of pi over 12. We could say that's tangent of, let's see, we could call that, 4 pi over 12 minus 3 pi over 12. If we reduce those, that would be tangent of pi over 3 minus pi over 4. Almost running out of room there. So those are both items that are on the unit circle. We know the values of tangent for those, so we can plug into our equation. So this is tangent of a minus b. Just a reminder of that formula. That's tangent of a minus tangent of b. Remember, the top follows the same sign, over 1 plus tangent of a times tangent of b. Okay, so let's plug in. That means we want tangent of pi over 3 minus tangent of pi over 4 over 1 plus tangent of pi over 3 times tangent of pi over 4. All right, so let's plug in. Tangent of pi over 3 is square root of 3 minus tangent of pi over 4 is 1 all over 1 plus tangent of pi over 3 we said was square root of 3, and tangent of pi over 4 was 1. Square root of 3 times 1 is square root of 3. Now, we do not want to leave a radical in the bottom, so we do want to multiply by the conjugate. So we're going to multiply 1 minus square root of 3 on top and bottom so that we can get rid of our radical on the bottom. When we do that on the top, let's think about what we're going to end up with. We have square root of 3 minus 3 minus 1 plus square root of 3 all over on the bottom. That becomes a difference of squares, 1 minus 3. So that's going to give us what? On the top, square root of 3 plus square root of 3 is 2 square roots of 3. I'm running out of space here. Negative 3 minus 1 is minus 4. On the bottom, 1 minus 3 is negative 2. Both of those are divisible by negative 2. That becomes what? Negative square root of 3 and then plus 2. So there is our final answer, negative square root of 3 plus 2. In your notes, when you're looking at ones like this, just a little hint. When you're doing a tangent problem, I would caution you to try to avoid any pi over 6s. Think about when we plugged in, we had tangent of pi over 3 minus tangent of pi over 4. Imagine if that was a tangent of pi over 6. Tangent pi over 6 is square root of 3 over 3, right? So then you're going to have a fraction on top and a fraction on bottom, which can make this even more complicated. Tangent's the hardest one anyway because you already have a fraction, but if you try to use a tangent of a pi over 6 or 5 pi over 6 or so forth, then you're going to end up with a fraction on top and a fraction on bottom. So just kind of make a note to yourself for the tangents. Try to avoid pi over 6 if at all possible. Okay, your others are fine because those are easier to deal with. Okay, but again, just kind of a word of caution there. Try to avoid that if at all possible. Okay, let's talk about the other way that we could use these. We might be given information about A or B or both, and then they might ask us to find a sum or difference based on that information. So let's look at what it starts out as. They have to give us some information about A and B. So let's say that they tell us that sine of A is equal to 12 over 13, and that A is between pi over 2 and pi. Okay, and then they tell us that secant of B is equal to negative 5/3, and that B is in between pi over 2 and pi as well. Okay, so both of these are in the second quadrant. Immediately, what you want to do is set up a picture. We're in the second quadrant. Okay, so let's look at A first. So A is in the second quadrant. That's supposed to be a right angle there. Okay. They tell us that sine is 12 over 13. Think about what sine is. Sine is opposite over hypotenuse. So that's 12 over 13. And this is an easily recognizable triple. Okay, our other side should be 5. And since we went to the left, we're going to call that negative 5. Now we could write out everything we might need. Sine of A should be, we already know, 12 over 13. Cosine of A is adjacent over hypotenuse, which would be negative 5 over 13. And tangent of A is opposite over adjacent, which would be 12 over negative 5 or negative 12 over 5. If I could get the negative to work there. Come on, there we go. Okay. Now let's do the same thing for B. I want to draw B in the second quadrant. And let's label secant, which is the reciprocal of cosine. So if secant is negative 5 over 3, then cosine is negative 3 over 5. Think about cosine is adjacent over hypotenuse, so negative 3 and 5. And then that's an easily recognizable triple, 3, 4, 5. So the other side should be 4. Now we can write out our values. Oops, not A. Sine of B, opposite over hypotenuse, would be 4 over 5. Cosine of B, we already said, was negative 3 over 5. And tangent of B would be opposite over adjacent, 4 over negative 3, or negative 4/3. Okay, now we have all the information we need to be able to plug into our sum and difference formulas. That's the whole reason for drawing those pictures and getting these values, okay, so that we can plug into those. Let's say they want us to find, let's just pick one of them. Let's say they want us to find sine of A plus B. Well, we know that that formula is sine of A times cosine B plus cosine, that's not an and, plus cosine A times sine of B. Let's plug in values. Okay, I'm going to have to go back because I forgot what we had. Okay, sine of A was 12 over 13. Cosine of B was negative 3 over 5. Plus cosine A, negative 5 over 13. And sine of B was, oops, wrong way. Sine of B was 4 over 5. Okay, so let's just simplify down. 12 times negative 3 is negative 36. Okay, 13 times 5 is 65. Negative 5 times 4 is negative 20. And then 13 times 5 again is 65. So we already have a common denominator. Negative 36 minus 20 would be negative 56 over 65. So that is the value of sine of A plus B. let's go ahead and go through. Let's say we want to find cosine of a minus b. Let's try that one. I don't think we've used that one yet. So that equation is cosine a cosine b plus sine of a times sine of b. Remember, the cosine is the opposite sign. Since there's a minus here, that is a plus inside the formula. All right, so let's plug in our values. I'm going to have to scroll back again. Cosine, negative 5 over 13 and negative 3 over 5. Plus, now let's look at the signs. 12 over 13 and 4 over 5. All right, so negative 5 times negative 3 becomes 15 over 13 times 5 is 65. Now that we can reduce, but remember we want to be able to combine, so I wouldn't reduce that. Go ahead and get your other part multiplied, and then you're going to combine. You may be able to reduce after that, but if not, don't worry about reducing to begin with, because then you're just going to have to convert it back to be able to combine. 12 times 4 gives us 48. And then 13 times 5, again, is 65. If we add these together, 15 plus 48 becomes 63. And then 65 is our denominator. We cannot reduce that, so it's good that we didn't try to begin with. And that is 63 over 65 as our cosine of a minus b. Okay, let's try a tangent one now. Let's say we have tangent of, let's do, what did we do? We subtracted before, so let's do tangent of a plus b so that we've practiced this one. So that's equal to tangent of a plus tangent of b over 1 minus tangent of a times tangent of b. Let's go find our values. Whew. Okay, tangent of a is negative 12 over 5, tangent b negative 4 over 3. You know what? I probably need to save some space. Let's move this over. All right, over 1 minus negative 12 over 5 times negative 4 over 3. Now, problem here, we've got to get a common denominator. So common denominator would be 15. Okay, that means we multiply the first one by 3. So that's negative 36 over 15 plus negative, now we need to multiply by 5, negative 20 over 15. On the bottom, we have 1 minus, and then 4 times 12, those would become positive because it's negative times a negative, is 48. On the bottom, 5 times 3 is 15. All right, so now negative 36 plus negative 20 is negative 56. Maybe, over 15. On the bottom, we need to get a common denominator. So if we're going to take 1 and get a common denominator, then that's going to be obviously 15 multiplied by 15. So that's 15 over 15. And then we're going to subtract the 48 over 15. So 15 minus 48 becomes negative 33. So we have negative 33 over 15 on the bottom. Now we want to flip and multiply. Remember, when we divide by a fraction, we can flip and multiply. So we're going to flip and multiply by 15 over negative 33. When we do that, 15s can cancel, negatives can cancel, and we end up with 56 over 33. I don't think that's reducible by anything. Let's see. No, that should be final answer. 56 over 33 cannot simplify down. And again, we didn't need a calculator for any of that. We could do all that fraction work by ourselves without a calculator. Okay. Those types of problems are really common, and being able to draw that picture as we did originally with A and B in the correct quadrant is very important, because we're going to have to do that for our double angle formulas when we start those the next day. So just make sure we're good with that. You've got a lot of practice problems that you can look through, okay? And please feel free to reach out if you have questions.